So let's talk about the goal of system design. So here I'm going to put a little bit of text on the page because unfortunately we're going to have to go through the definition of why we need system design, but I promise you this is one of the only slides that is this much text. The goal that we have when it comes to system design is we want to engineer and build systems that meet the needs of the business in a coherent, efficient, and organized way. We do this by designing the architecture, the interfaces, and the data of the system. These three terms are very key: the architecture, the interfaces, and the data. And we're going to discuss what each of them represent. Before we do that, though, we need to ground our understanding in the core principles that drive system design. So there are mainly two that we want to focus on. There is availability and there is reliability. What you are trying to build the system to achieve is availability and reliability. You want to build a highly available and a highly reliable system. Of course, you want the system to also deliver the core function that your application or your business is aiming to achieve. But the main idea of why you're making these decisions in designing your system is so that you can maximize the availability and the reliability of the system itself. Now let's talk about each of them. Let's start with availability. Availability is pretty much the percentage of time within some given period that your system or application can actually be used and will perform the desired function of what it's supposed to do. So think about it like this. You have a system, an application that we've built, and you know that users want to access and use it for some specific purpose. If they're able to access it, then it's available. If they're unable to access it because maybe your system is crashed, your network is failing, your hardware is burning, whatever it is, then it is considered not available. So when we're talking about availability, we're trying to evaluate the percentage of time within some specific period that your system is up and running and performing the desired function. So this can be calculated with a very simple equation, which is the uptime divided by the uptime plus the downtime. Here, again, reiterating what percentage of our system is functioning in a given time frame. Now, the time frame is going to be the uptime plus the downtime because that represents the total amount of time that our system is trying to be accessed or accessible. Essentially, as long as the system has been in existence, that is uptime plus downtime. Now, functioning is just uptime because, as I mentioned, if there is uptime, then that means that that is when your system is accessible and operating. By taking this equation, let's plug in some values and understand what we're talking about here. Let's say that the uptime is 300 hours, and let's say the downtime, for some reason, let's say we had to roll some updates, and these updates put our system down, and in total it took 15 hours. The total amount of time, the time frame that we were actually trying to utilize our system was 315 hours. That is the total amount of time that we're trying to understand. Within those 315 hours, only 300 hours were available. The other 15 hours, our system was down, hence the downtime. When you perform this calculation, you get a value of 0.952. And when you convert this to a percentage, it's 95.2%. That means our system was available for 95.2% of the time within that 315-hour time frame. That is availability, and that's the main calculation. Now, the reason why availability was one of the core principles that drives system design is because we are trying to figure out with our system that we're designing how to make it as accessible as possible to people that actually want to use it. The whole idea is that we're focused on actually delivering the product. When you think about whether or not the product is good, that is product design. That is where you are working on the actual application and trying to figure out if the application actually satisfies the needs of the user. That is a completely different thing from system design. System design is pretty much you trying to figure out how do we make it so that our solution is actually available in the first place? Meaning that if a user wants to use it and they're requesting for the website to do what it needs to do or what it says it's going to do, is it going to do it for the majority of the time that I need it to do it? This is system design. How do we maximize the uptime? Now, generally speaking, when it comes to evaluating how much uptime your system has, you use the 9s of availability. And this is pretty much just 1 to 9 of these 9s. And this is the percentage of uptime you want to aim for. 1 9 is 90%, 9 9s is 99.999 with the trailing remaining amount of 9 so that you get 9 total 9s. Here, with this aim, you essentially look again within a certain amount of time. So within a time frame of 1 month, let's say, for example, how much downtime are you allowed to have? If you have 1 9, then you have 72 hours. Now, if you are at the maximum 9 9s, the most downtime you're allowed to have within 1 month is just 2.6 milliseconds. That means your system is down only for 2.6 milliseconds. 9 9s is an extremely, extremely difficult to achieve amount of availability. Most companies are aiming for maybe 2, 3, or 4 9s. Generally speaking, unless there are lives at stake, let's say for something like a life support device, then you need to maximize the actual availability of that system. Because if the system goes down, then people might be dying. And that is an extreme case where it's worth the investment. Because remember, the higher in the 9s you go with availability, the greater the cost it is. It's really expensive to maintain that high amount of availability. Much of where you're aiming for in your availability depends on where the business is at as well and the context of what your business aims to serve. If you think about businesses like cloud architecture platforms, whether it be Microsoft Azure, Google Cloud Provider, or Amazon AWS, most of the services that they offer are around 2 to 3 9s, maybe 4 9s. And that is the maximum. And they are mission critical products that essentially the entire tech industry relies on for their apps to work. So this is even for them really high, just getting to 3 and 4 9s. Generally speaking, we consider most applications to be very mature if they're at 1 or 2 9s already. So that's just something I want you to keep in mind when it comes to availability. But what you're looking at is really just a calculation of how to determine how much your system needs to be up in order for you to hit these numbers. If we expand this out to 1 year, we'll see that these numbers are generally quite more forgiving. Even then again, as you go anything above the 4 9s, it becomes extremely small. There are such low amounts of downtime. Again, most systems don't need to be that available. But here, hopefully, you can see the value of why we look at availability to determine the quality of the system that we have designed. And what we're going to use this availability to help us understand is we're going to use it to ground and understand why we design these different components that we've looked at the way we do. Why the decisions that you're making revolve around achieving better availability. And that's why availability is one of the core principles of system design. So now that we understand availability, join me in the next video where we will talk about reliability. I'll see you there.